Well, in this video, we will go over all the steps of finding uh, the known the volume using known cross sections. So we will slice. So imagine we will slice the region of a perpendicular to either the x or y axis to create a certain shape, such as a square, equilateral, triangle, isosceles triangle, right triangle, semicircles, and rectangles. Each shape will have different formulas. Okay, so yeah, this let's look at this image here. So we have three lines or three equations. We have the half of the parabola y equals radical x, and we have this vertical line x equals 4, and then this horizontal line y equals 0. And somehow we're trying to find the volume of this. Well, how would we do this? You see, this is only the area. So how could we find the volume from this point to this point? So imagine flattening this image down into a surface. So imagine flattening this down and you have this 3D image. Now what I want you to do is imagine building up to create some type of shape. So if you here you have this singular shape, keep adding up vertically and you have some type of shape. So that's what we're going to do. Yes, so with these shapes, you can actually you can make different. So if I took a piece of like from this image here, and if I took like a square or a rectangle, yeah, that builds some type of shape. And so let's say so let's pretend we took a piece of square of this shape. And if you recall, has a square has all the sides are equal, right? You need a length and you need a width. So yeah, if you use a square, remember in a square, all sides are equal. If you took all those three squares, it creates an image. So look what we have here. So here what we have, this is what we originally had, right? If we took slice it into squares, you could find the volume, right? So if you took an infinite amount of squares, you would create a solid shape. So what essentially we're trying to do is make slices of squares, and the squares creates different heights, and if you create an infinite amount of squares, we can create a solid mass of the figure. Okay, so how do you find the volume using known cross sections? So we're not finding area, we're finding volume. First, you need a lower and upper boundary, and then you need to find the top minus the bottom, and then we have to square it because remember the area of a square is length times width. So right here, this is just right here. This is just one area of one square, right? But we have to find it from here to here. So A and B starts with the start slash stop of the shaded region. So A is the starting point and B is the ending point. And then the top and bottom function curves that creates a region, right? Here's your top. The top is obviously going to be different. And then side of a square is top minus bottom. So like I said before, you don't have to take squares. You can actually take other other shapes. You could take out an equilateral triangle. So for this, let's talk about all the formulas. So if you decide to take a square, it's from the integral a to b from top minus bottom squared. If you decide to take a triangle, it is the square root of 3 over 4 from the integral a to b, and then top minus bottom squared. If you decide to take an isosceles triangle, it's going to be 1/4 from the integral a to b of top minus bottom squared. If you decide to take a right triangle, it's going to be 1/2 from the integrals a to b, top minus bottom squared. If you decide to take a semicircle, it's going to be pi over 8 from the integral a to b, top minus bottom squared. And if you decide to take a rectangle, it's from the integrals a to b, or they'll give you a height, and it has to be constant. If it's not, you're gonna have to put it in here. So if the height was like, for example, 3, you could put 3 here. If the height was 3x, then 3x is not a constant. So what you're gonna do is put it here and then simplify. So just be careful with the height. It has to always be constant. So for a rectangle, it's h from the integral a to b, top minus bottom squared. Let's do an example. So example 1 says find the volume when we have 3 lines, y equals radical x, square root of x, x equals 4, and y equals 0. So let's first draw the image to see what we have. So we know that radical x is like a parabola. So it looks like this. So this is y equals radical x. And then the vertical line x equals 4, that's easy, right? Let's pretend this is 4. Draw a straight vertical line like that. And then y equals 0 is pretty simple. It's just this horizontal line right here. Maybe I should use a different color. Right, so this is y equals 0. Okay, so somehow we have to find the volume using not just squares, but let's use all of our shapes: squares, equilateral, triangle, etc. Okay, so let's start with a volume of using a square. It is from, so what are A to B represents the stop and end. So we start at 0 and we end at the 4. And then it's going to be the top minus the bottom. So the top is the radical x minus the bottom, which is y equals 0 or 0, and in terms of dx. So be careful with the d. We have to make sure everything's in terms of x. And then don't forget we have to square this. So if you kind of simplify it, it's going to be 0 to 4, and then radical x minus 0 is really radical x, and then we have to square that. Now that just becomes x dx, and then so this would be your volume. I'm not going to go any further because you know how to integrate this, right? So this would be the volume using a square. What about an equilateral triangle? So let's see here. So the formula for equilateral triangle is square root of 3 over 4 from the integrals 0 to 4 times square root of x minus 0 squared dx. Okay, so what do we know? So It's the same thing, top minus bottom squared. The top is radical x and the bottom is y equals 0. And when we got to square it, boundary, the stop and end point still 0 to 4. The only difference is we put the constant radical 3 over 4. So when you simplify that, that's going to be square root of 3 over 4 from 0 to 4. And then radical x minus 2 squared is really radical x squared, which is just x dx. Okay. Now, what about an isosceles triangle? Isosceles triangle is from, so it's going to be 1/4 from the integrals 0 to 4, and it's going to be the top minus the bottom. The top is radical x minus the bottom squared dx. And what else? So yeah, we'll just leave it as this. I'm not going to simplify it. You can do this, right? I just wanted to show you this, like the setup. And then what about the right triangle? So the formula for right triangle is we have to take out a constant of 1/2 from the integral 0 to 4, and then it's still top minus bottom, so radical x minus 0 squared dx. And then let's talk about semicircle. It would be from pi to 8, yeah, pi 8, from the integral 0 to 4, radical x minus 0 squared dx. I'm just going to leave it like this because you can simplify that a bit more. Okay, so those are all the shapes you could take out from this, uh, and you'll somehow get. So if, yeah, just imagine this picture. If you took out squares, tiny little squares from 0 to 4, you can find the volume. You'll get a volume, and if you took tiny equilateral triangle from 0 to 4, you could find the volume. So you get the idea, right? Okay, so let's start. What about, let's move on to example 2. So example 2 says we have y equals x squared and x equals 2 and y equals 0. Find the volume for all known cross sections, and then you have this symbol which means perpendicular uh, to the x-axis. So what this means is everything will everything will be in terms of dx. So you have to be careful because sometimes they don't put everything in terms of dx, or if they say y-axis, everything has to be in dy, right? So just make sure everything will be in terms of dx. So here we have this image. And y equals x squared is a parabola or like this. And what else? X2 is a vertical line. Let's pretend here's 2. It's a vertical line like that. And then what's the other one? Y equals 0. It would be right here. So this is the area this is the region you care about the most, right? This is where they all intersect. So, what would be our boundary? What would be our stop point and our end point? So I think, yeah, our stop point will be at 0, and then our end point would be at 2. So yeah, the width is from 0 to 2. So let's do our cross section. So let's start with the square. So everything is good. Everything's in term of x. We don't have to convert anything. So start with the square. So if we decide to do a square, it would be from 0 to 2, and then it's going to be top minus bottom. So wait, let me write this out. The coefficient from A to B, top minus bottom squared. So it's going to be, the top is x squared minus 0, and then square that dx. So that would be from the intervals from 0 to 2. And we know that x squared is x4 dx. And I'm not gonna do it. You can do this, right? You can just finish this off. But I just wanted to show you the steps. What about equilateral triangle? So the rule for equilateral triangle, the coefficient is going to be right up with 3 over 4. Start point was 0, end point is 2, and then it's still top minus bottom squared. So it's going to be x squared minus 0 squared dx. So that is going to be simplified as radical 3 over 4 from the interval 0 to 2. X squared minus 0 is x squared, and then you square that, so that's x4 dx. Okay. And then let's do the isosceles triangle. So it's going to be coefficient is 1/4, and then from 0 to 2, and then it's going to be x squared minus 0 squared dx. And when you simplify this, it's going to be from the 1/4 from intervals 0 to 2. X squared is x4 dx. What about right triangle? So it's going to be coefficient, which is 1/2 from 0 to 2. And then it's going to be x squared minus 0 squared dx. And that's going to be 1/2 from 0 to 2 x4 dx. And what about semicircle? It's going to be pi over 8 from the integrals 0 to 2. Still the same top minus bottom, so it's going to be x squared minus 0 squared dx, which simplifies as pi over 8 from 0 to 2 x4 dx. Okay. Oh, okay. Let's move on to example 3. Okay, so example 3 says y equals, given y equals x squared, x equals 2, y equals 0, find the volume for all known cross sections perpendicular to the y-axis. So now it's like it's almost exactly like example 2. The only difference is they want it in terms of y because we have to be perpendicular to the y-axis. Okay, so this, let's just draw the image again. So we have three lines, y equals x squared, x equals 2, and y equals 0. So that is easy, right? Just draw that image. Okay, so y equals x squared is a parabola like this. And then x equals 2 is going to look like this. And y equals 0 is like this. So what do we, yeah, we have to be in terms of on the y-axis dy. So we are no longer perpendicular to x, and we are perpendicular to y. So just note our top and bottom will be different. Okay, so just so what happens is this will now be our top, and then this will now be our bottom. Okay, so if we have to put everything in terms of y, uh, well, wait. First of all, it's not going to be. It's no longer going to be from 0 to 2. So what is our new boundaries? Well, what we're going to do is substitute x equals 2 into y equals x squared, right? We have to put it's up along the y-axis. So this is this is our top and this is our bottom. So we have to find this point. So I believe this is 0. And then what's this height? Well, we don't, this is why we're going to substitute x equals 2 into y equals x squared. So that is going to be y equals 2 squared, which is y equals 4. So it's going to be volume equals 0 to 4, and then it's going to be top minus bottom. So now the top is the vertical line 2. Wait, so if we can't do 2 minus, and then the bottom will now be x squared. Why can't we use this? We can't use this because everything has to be in terms of y. So this is not all in terms of y. But that's okay. We can adjust it. So we have y equals x squared. Just simply solve for x. So if we have y equals x squared, just solve for x. So I'm going to square root both sides, and then you get square root of y equals x. Well, actually, you get a plus or minus, but I think we're going to use the plus. It would be more, I don't think we'll use a negative. So our volume is going to be from 0 to 4, and then it's top minus bottom. So our top is still 2, minus our bottom is now square root of y. Square dy. Okay, so let's do the square. So it's going to be from 0 to 4, and then it's going to be 2 minus square root of y square dy. Let's do the equilateral triangle. It's going to be square root of 3 over 4 from the integrals 0 to 4 of 2 minus radical y squared dy. Okay, then what about an isosceles triangle? It's going to be 1/4 from the integrals 0 to 4 of 2 minus radical y squared dy. What about a right triangle? It's going to be 1/2 from the integrals 0 to 4 of 2 minus radical y squared dy. And then what about a semicircle? It's going to be pi/8 from the integrals 0 to 4 of 2 minus radical y squared dy. Okay, so that was a little bit more challenging because we had to like convert it in terms of y. Do one more example. Let's start with example. This is our last one. Example 4. Given that y equals square root of ln of x and x equals e, uh, on the x-axis, find the volume. Find the volume for all known cross-section perpendicular to the x-axis. So I think everything is in terms of x, but I don't know what this graph y equals square root of ln of x. I know that x equals e is a vertical line because e is about what, 2.7? So it's a vertical line about 2.7. So what do we know? Well, I know we kind of know how to graph y equals ln of x, right? Y equals ln of x. We know that, right? That kind of would look like this. Y equals ln of x has an x-intercept of 1, comma 0, and it would look like this. And x equals e would look something like this. Say this is like e, which is like about 2.7. Now, so this is y equals ln of x. We want y equals square root of ln of x, right? We want that. So what that is going to do is if it just flips up. So imagine this flipping up. So imagine this flipping up. It would look something like this. Doesn't go below the x-axis like that. And so the area, the area is, or the region is from here. Okay, so if we're doing across the x-axis, this would be the top, this would be the bottom. What else do we know? So everything is, what would be our boundaries? Our boundary would be from this point here, and then it stops at E. But I don't know what this, oh, it is 1, right? But if you're not sure, what we could do is, so we have, what we could do is set square root of ln of x equals to 0. So sets this to 0. That's going to be square root of ln of x equals to 0. And then if you try to solve for x, you're going to square both sides. So this cancels, so you're just left with ln of x equals to 0. And then how do you solve for x? Well, there's an ln, so you can take the e both sides. So this cancels, so you're left with x, and then e to the 0 is 1. Okay, so this point here is 1. So let's start, they want all cross sections, so we'll start with the square. So the square is going to be from 1 to e, and then top minus bottom. So the top is the square root of ln of x. Minus 0 squared dx. What about the equilateral triangle? Which is square root of 3 over 4 from the boundaries 1 to e. Top minus bottom squared, so square root of ln of x minus 0 squared dx. Okay. What about an isosceles triangle? Which is 1/4 from the intervals 1 to e. And then square root of ln x minus 0 is the same thing. So it's going to be square root of ln of x minus 0 squared dx. And then what about the right triangle? It's going to be 1/2 from the integrals from 1 to e. And then it's going to be ln of x dx. Or it's the same thing to parentheses ln, sorry, this should be square root of ln of x. But it simplifies as, when you simplify square root of ln x minus 0 squared, that just gives you ln of x dx. And then what about the semicircle? So it's going to be pi of 8 from 1 to e, and then ln of x d of x. Okay, so we just figure out how to do the volume of known cross sections. Okay, so we'll stop here.